Continuing on with our real-life Boolean examples, let's click the one underneath Leap Year Program, which is this class called Paycheck. And I'm going to open this up. Now, unlike Leap Year Program, which was a console program, Paycheck is actually a class. So look, does the Paycheck class have any private instance variables? It does. One is the hours that I've worked, which is a double, and the other is my hourly rate, aka how much money I'm making per hour, which is also a double. Look, the constructor is already made for me, and it looks like my job is going to be to write this method called getAmount. If you've ever worked a job before, you know that what you expect to get on your paycheck is not actually always what you get, and that's because of taxes. So you have the amount that you kind of make with your base salary, and some amount of that gets taken out for taxes that go to the government. There's also other rules with regards to your paycheck, things like overtime. In California, if you work more than 40 hours a week, or I believe more than 8 hours in a day, you actually get time and a half times pay. So 1.5 times whatever you were making before for those extra hours. So our goal in this question is going to be to write this getAmount method, which actually calculates the paycheck that's not just the hours you've worked times your hourly rate. So I have some rules here actually as to how the paycheck is going to work. I'm going to have those kind of next to our program as we're going through doing this. Here we go. So we're going to write the getAmount method of the paycheck class, which should return the amount of money you actually take home at the end of the day in your paycheck. So taking out taxes, figuring out overtime, and funny enough, you're a part of a union, so you have to deduct for union dues. Calculating your paycheck is actually a little complicated. If you make a certain amount of money, you'll be in a different tax bracket than other people. So we're going to have to deal with that. So let's go in order of actually all of these bullet points on here. So I'm going to get rid of the stuff inside getAmount right now. And let's do this. Let's first start by calculating our base pay, which is the number of hours we've worked times the hourly rate. So I'm going to do double base equals hours worked times hourly rate. Now, let's say I worked for 40 hours and I was making $10 an hour. Sad, but maybe. Then my base pay should be $400. Now we have to handle overtime, which is if we've worked more than 40 hours in a week, we get overtime pay. For every hour that we work beyond 40 hours, we get an extra 50% of the hourly rate. So let's do this. If hours worked is greater than 40, doesn't my base increase by some amount? And that amount is actually how many hours I worked over 40 times my hourly rate divided by 2. So half my hourly rate. So let's do hours worked minus 40 times hourly rate times 0.5. All right, so there's our overtime. And now we have to figure out this tax thing. So it looks like I deduct a certain amount depending on my pay bracket. So let's do this. I think this is just going to be a nice little cascading if statement. If base is less than 200, it looks like I take out 11%. The other way to think about this is what I take home is my base times 0.89. So let's do base. Remember, I can do times equals, which works the same way plus equals does, but for multiplication. 0.89. Else if. Now, it's really common to look at this chart and think, oh, I have to check 200 is less than or equal to pay, and pay is less than 400. But I'm going to urge you actually to not do this. Why do I actually not need to check the bottom condition here? Well, assuming I made it to this part of my cascading if statement, that means it's guaranteed that my base pay is greater than or equal to 200 because if it wasn't, I would have gone into this first if. You never need to check for things that you've already checked for. So save yourself kind of the brain power and the typing by knowing kind of what you've already checked for and not needing to check for stuff that has already been done. So here, base times equals 0.85. Oops, let's Let's put a semicolon there. Else if, and I need to call this base, else if base is less than 600, base times equals 0.82. Else, I think in the last one, base times equals 0.76. Notice too how I'm not returning here. Remember, return ends the method. I still actually have one more thing to do here. It says, in addition, $14 is deducted from your paycheck for union dues. So sad. So let's do base minus equals 14. And then let's just make sure we don't have a negative paycheck. So if base is less than 0, we're going to return 0. Else, let's return base. Now, this wasn't a problem where I was actually returning a Boolean, but we definitely did use some of our Boolean logic to do this, right? There's clearly a lot of if statements in here. I had to think about what I needed to check to be able to accurately do my paycheck. This is really the first time that we've seen a problem like this where we've been writing one singular method from within a class where I'm kind of given the private instance variables and given the constructor. And really my only job was to write code inside this getAmount method. You actually have a test coming up in a few classes, and your test will feel very similar to this. And in fact, the AP at the end of the year will feel very similar to this. On every single test problem, you're going to be given some class, maybe something like the Paycheck class, where you're told, what are my private instance variables? Maybe you're given the constructor or a method or something else, and each part of the question will actually be to write a singular method. So you could imagine writing the getAmount method could have actually been one part of your test. We're going to get used to what this format feels like of kind of writing methods within classes we've never seen before as we go further towards the test. But this is what it's going to feel like pretty much for the rest of the year.